Now we need to look at hydroelectric power, or in particular, pump storage systems. Now this is when power is derived from moving water, hydroelectric. The energy transfer is basically from gravitational potential energy, which means that the water is at a certain height. It loses height, and in losing that potential energy gains kinetic energy. Then that kinetic energy is changed into electrical energy by turning a dynamo or a generator. So for example, 1 kilogram of water travels down 50 meters each second. How much energy will that produce? Well, the gravitational potential energy is turned into kinetic energy. Use MGH. M is 1 kilogram, G is 10, and H would be 15. So it's 15 times by 10 times by 1, which will be 150 joules per second are converted. Then this kinetic energy has to be turned into electrical energy. However, an electrical generator will only be 20% efficient or 30% efficient, so it will only be 30% of this, which will be around 40-50 joules per second. Let's look at a bit more detail at the pump storage system. You have the gravitational potential energy is turned into kinetic and then electrical energy. So first of all, you need some electrical energy. Then what happens is that water runs downhill, potential energy turns into kinetic energy. Then this energy, this kinetic energy, makes the turbine turn, and that produces electrical energy. So you're able to produce your electrical energy needs by changing gravitational potential energy into kinetic energy, which turns into electrical energy. However, what happens at night is that there's a surplus of electricity in the national grid. We don't need all this electricity. So what we can do is actually put the turbine in reverse. So a generator in reverse is basically a motor. So we turn this generator into a motor, make it run kind of backwards, if you like. So the electricity turns this motor, and then it pumps the water back up the hill. So this electrical energy that you have the surplus of turns into kinetic energy of the water particles. Then this energy is turned into gravitational potential energy. So you see with the red arrow here that this kinetic energy is turned back into potential energy. That's why it's called a pump storage system. So the summary. We have basically, in a pump storage system, we have reversible energy conversions. When you need electrical energy, you basically have gravitational potential energy turns into kinetic energy. Then this kinetic energy turns the turbines, and you get electrical energy out. When you have a surplus of electrical energy, you do the same thing in reverse. The electrical energy that you have turns into kinetic energy as the water is pushed uphill, and that's turned into gravitational potential energy again. Here we have something called the Three Gorges Dam, which is in China, which is a new project which basically produces a lot of China's power. And if you can read that, it says Three Gorges Dam. It's able to produce 18,000 megawatts. It has a head of 80 meters, so there's a difference in height of 80 meters. Now, how can you find the flow of water through the turbines if it produces 18,000 megawatts and the flow is 80 meters? Well, if you take 1 kilogram, it drops 80 meters. What is the change in energy that it has? How many of these kilograms do you need to produce 18,000 megawatts? This is a question that we could try to do in class.